So welcome everyone to Starknet Foundation Developer Basecamp session 4. I'm gonna do a quick reintroduction before we write smart contracts. So these are the teams. I think everyone already knows us. It's David, me, Siton, and Truth. So we'll be helping you throughout this Starknet journey. If you have any questions, you can drop it in the Zoom Q&A box or in the Discord channel. Another recap, I've been repeating myself every week. So for the scoring system, we have different points to get the graduation. So for the quizzes, every session, at the end of the session, we will have a 4-question quiz. So each question that you get correctly, you get 1 point for your graduation. And last week was an exception. So we sent out the Google Forms for the quiz, but that's just the exception for last week. And an important thing is homework. Many people have been asking. So the homework, we don't really have weekly assignments, but we have one homework throughout the whole program. So what you need to do is to submit the homework at the end of the program, and the deadline is September 14th, a Sunday. And it will start this week, which means that the homework is to follow live coding throughout session 4 to session 6. So it starts today with David's session on smart contracts, and next week we will test the smart contract. And in the last week, on session 6, on September 11, we will build a front end of the app that you have been building. So it's like a continuous homework, not a weekly assignment that you have to submit every week. So the homework is you follow live coding. You can follow along live during the session, or you can follow along live and then watch a recording any way you want. And at the end, you publish the code to GitHub. We will send out a link to can send out a form to collect your GitHub repo link, and then it's done. So basically, you just need to follow live coding class, and that's it. You can do it everything all at once before the deadline. That's fine, but we will recommend that you code little by little every week, so you don't have to stay up late at the end of the program. Another 20 points you can get by completing the STRK links. So what you need to do is connect your GitHub, you join the STRK links, and you complete all the coding challenges on STRK links, and you can get the 20 points. And I have seen already many students have completed it. If you have any questions, drop it in Discord. Truth and David will be there to help you. Another reminder of the graduation criteria. So we have 3 status. You can be either attendee, graduate, or graduate with honors. And if you want to be a graduate or graduate with honors, it's highly recommended that you complete the quizzes, complete the homework, and also complete the STRK link so you can get maximum points that you can get. And on the sheet, I also shared it in the chat before. You can check your points right here, this link. It's not like real time, so I will update it like every few days. So if you finish the STRK link and you jump right on the point sheet, you won't be able to see it updated, but I will update it as soon as I can. Another important thing, exciting thing to announce is that on session 1, we mentioned that Basecamp is just the first step of your Starknet journey. So the next step is a hackathon, and we have a hackathon coming up. It's from September 15 to October 15, and it's online, so you can basically join from anywhere. And we have confirmed several tracks, and it's still ongoing, but we have confirmed, for example, Bitcoin, DeFi, gaming, payments, privacy, and we also have a general track, so in case your product doesn't fit into any specific tracks. For the prices, we have confirmed 30K. It's going up as well. Registration will open next week, and we'll also have more information coming up in September. Another thing important to share is also that we realized that we have been running Founder Basecamp, Developer Basecamp many times, and we realized sometimes developers want to contribute their skills, but they don't have a project yet to contribute their skills to. And we realize, on the other hand, there are founders who have project ideas, but they don't have the technical skills like you do to write what they have in their mind. So what we're doing now is to matchmaking developer and founders, so you can both join a hackathon together. So we have a form right here. You can fill out the form to add your profile to the talent pool. So the founders at the Founder Basecamp can go on this page in the talent pool, and they can see your profile. So you can put your contact information, your experience, or anything you would like to share. And at the same time, you can also go on this talent pool, and the founders will also submit the form with their project ideas. So you can go on there to see which founder is looking for developers, what are they building. If you are interested in their project, feel free to reach out to them. And also, Another thing is next week on Tuesday at 5 p.m. CST time, around the same time, but on Tuesday, it's a Founder Basecamp demo day. So some of the founders will present their projects. If you find it interesting, you can join the Zoom call here to listen to their live pitch. And if you like their ideas, you can reach out to them on the talents pool. So here, I'm gonna quickly demonstrate a little bit the form. Can you see my screen? Perfect. Okay. You can see you're speaking. Yeah, so if you go on the talents pool right here, you can see, for example, projects and founders. There are several founders already filled the form. This is me. Don't click on this. And you can go on the name, for example. Okay, this guy called Superman. And you can open inside Peak and you can see more information about his project, what talents he's looking for, anything else he wants to share, and his contact information. So if you are interested in this project, you can click on open and you can see more. At the same time, if you fill out the form, your profile will become here. So for example, the founders, they are interested in looking for more developers. They will go up here and see all the developers. And this is me as well. Okay, so that's what I would like to share about the hackathon. Yeah, and then same, if you have any questions, you can drop in the QA box. You can write in Discord, you can email me. There's also a link for the resource page, and also there's the page to check your graduation points. And today we are in session 4. We'll talk about Cairo smart contracts, as I mentioned. So now I will pass the mic on to David, and if you have any questions, drop it in the QA box, and me and Truth will answer it for you.
Thank you, Sutton. I'm gonna take over, share my screen. Okay. Yeah, so before we start, I just want to address one question of the quiz, question 1, and that's because we noticed that most people got it wrong. So I just want to clarify the question and the answer. So the question was, why should you avoid using failed 252 in your code? If you recall, in the session, I had a whole session dedicated to faileds, some of the issues that it had, but the reason why it exists, right? Some of the issues that I mentioned is that math behaves differently because the underlying CPU uses field elements. It doesn't. The math behind it is the math of field elements. It's not binary math as in a regular CPU like your AMDs or your Intel. That's why every operation is done in modulo, and so overflowing is just a natural occurrence in field elements, which is not something that you want in behavior of smart contract. You don't want the balance to suddenly overflow and go back to whatever different number, back to 0, back to negative, or even going below 0 for a balance, for example. That's why I was really emphasizing that you should always use unsigned integers or signed integers for your code, and only use failed if you really know what you're doing, right? Because failed is the only place where an implementation detail of the CPU architecture of Cairo actually leaks into the language, right? So that's why only use it in specific situations. And one of the situations that actually could make sense is to use a failed as a short string. And a short string is just basically taking an ASCII character and convert it into a single failed. That's why you're going to be limited to only 31 characters, which is actually very limited as well for like error messages. You want error messages to be longer than that. So even if you want to handle strings, it's better to use byte array that we also mentioned last time instead of faileds, because in failed you have this limitation of 31 characters. So having said that, the correct answer for this question is all of them. So you should avoid failed because it couples your code to the underlying computer architecture that is subject to change. One of those changes that we're trying to implement, or Starknet is working on, is coming up with a new type of field element that is much smaller, which gives you a lot of advances in performance. This is why this 2 prover, the next generation prover, is so much more performant than the current one, is because Starknet actually came up with a new type of field element that actually fits in 31 bits. It's much smaller than 252, and that has a bunch of advantages. And I also mentioned that fails can overflow and underflow. It's just natural way that the math works in field elements. Integer division, it doesn't work integer division. It works in a different way, in the way that field elements supposed to work for division, but not the way you expect. And because if you use it as a short string, you're limited to 31 characters. So hopefully that clarifies the role of failed and when to use it and when not to use it. And okay, so to recap session 3, I was doing mostly live coding for the whole session. I miscalculated the time that will take me to go through all the code that I prepared. So I only covered maybe half of what I prepared. That's why I re-recorded the whole session. We put it on YouTube and you share it with you. But it ended up being like a 3 and something hour session, so very long. But to recap everything that I covered in that YouTube video that I shared with you, I show you how to install dependencies using StarkUp, which is like a single command line that gives you all the dependencies in once, or using a Docker image, which is my preferred way, but you're required to have Docker running in the background. I show you how to create a project with Scarp. Then I also show you that the way I was verifying the code that I was written using unit tests. So I show you how to actually write these unit tests or the attributes that are required. I mentioned how to install dependencies on your project from the Scarps registry. In this case, we implemented Alexandria Math for advanced mathematics. Then we went into Cairo itself. I showed you like things like the ownership model, and related to that, you have the shadowing, you have mutability with the mod keyword, you have snapshots with the add, you have references with the keyword ref as well. So these are different ways to handle this ownership model of Cairo, which is very similar to Rust as well. We talk about functions, fields, integers, in this case, unsigned integers, signed integers. We talk about casting to going from one type to a different type, and then constants. We talk about enums in general, and then specific enums like result and option that are available in the language as part of the prelude, and then how to use match to capture specific members of the enum. And finally, we talk about structs, traits, and arrays. Okay, that's what we cover in session 3. Now, topics for today. We are gonna be using a project called Scaffold, which is a project specifically made for Starknet to build web applications for Starknet. And we're gonna show you how to run a local Devnet. We're gonna show you also how to deploy your smart contract to that local Devnet, how to do manual testing with the debugger that comes with Scaffold as well. We're gonna have a 10-minute break. We're gonna create a counter contract and then interact with other contracts with the dispatcher, and then use OpenZeppelin Components. And finally, the quiz. Okay, so some large languages. Well, it's very long message. Maybe you can compare, make it smaller. And using an LLM to answer the question. Yeah, okay, that's why we didn't share quizzes as a take-home assignments. But let's see what it says. So LLM says, so no, everything is false. Anyway, it's too long to read here. Okay. I'm going to jump now to show you Scaffold. So Scaffold, let me give you a sec. Scaffold Stark, that's the name. I'm going to put it here in the chat. All right. So Scaffold, as I mentioned, is a set of tools that makes it very easy to create web applications for Starknet. They're actually working on creating a version of Scaffold that is for mobile apps, and also to expand what Scaffold have. I know they're working on having like a local indexer and also like a local block explorer as well. But for now, we have plenty of tools to play with. And to use it, you need to have Node.js installed in your system. And in my case, I have 21.1.0. Making the screen a bit bigger. So to create a project with Scaffold, we are going to use npx create Stark. So this is, you will need to have this package. Actually, it will come and pick up the package from the npm registry. Let's use the latest version. This is actually going to use Scaffold under the hood. So first of all, it's going to ask you for the name of the folder. So it's going to create a new folder and then put all the dependencies there. And let's call it SN app, Starknet app. For now, I'm not going to install dependencies because I don't have Yarn installed in my host OS. I have it in my Docker image. So it's going to create all the essential project structure. So let's go to the folder. Oops. So you see that comes with all these files, created by Scaffold. And maybe let's open this in an IDE. I'm going to use cursor this time. Here's the font size. And let's take a look at what it comes with it. So we have, first of all, this is like a Node.js workspace, actually with Yarn. It has a package.json that defines two different packages. So this package is going to be with everything related to the smart contract, and testing for the smart contracts are going to be located. And here is going to be everything related to the actual front end of the application using Next.js. And it has a lot of scripts that we're going to be using. But the first step will be to actually now install dependencies. But for that, I need to make sure that I run the IDE within my container using Docker. If you use start up, you have dependencies globally installed. You don't have to do this step, but I'll do it because I prefer this container with Docker. So just so you know, I have Docker running in the background. So if you want to display this, you need to make sure that you also have Docker running and with enough resources as well given to it. Let me try to show you. Here's my Docker running, and it has plenty of resources to play with. I just give it all of it of my host OS. Okay, important. So now I go back here and I can go to View, Command Palette, and Rebuild and Reopening Container. We did that last time. And notice that it comes with a dev container file already in place. So you don't have to create that as last time around, right? And it's actually asking for the version 2.11.4. So we're going to be able to use, we're going to use a lower version that we did last time just because Scaffold still hasn't not updated dependencies. So we're going to make sure that we use what they recommend to use. So View, Command Palette, and Rebuild and Reopen. This is going to open the launch the container, launch the IDE inside the container. So now I should be able to have dependencies. So Scarp version 2.11.4, SMForge version 0.45, and Starknet Devnet version 0.4.3, right? These are the three main dependencies we're going to use. In the image, I also have a Yarn available. So if you see Yarn version, first of all, I'm going to try to download it. So say yes. Had 3.2.3. Okay. What else to show you here? So now in the container, I mentioned we have these two packages, right? So this is for all the smart contract for frontend. And in the SM Foundry, you're going to see that if you go to contracts, we're going to see some of the same files we saw in the last session. For example, the scarp.toml, right? This is the entry point for any starter project. And the main difference from last time is that notice that we have a Starknet as a dependency. Because in session 3, we use just like a plain Cairo, just for create Cairo programming language, Cairo programs, not Starknet smart contracts. For this time around, we're going to use Cairo to create a smart contract for a Starknet. So you need to define Starknet as a dependency. So new attributes or new macros are going to become available for you to use. And we're going to use some smart contract from OpenZeppelin. And OpenZeppelin has a whole suite of contracts written in Cairo, already verified, audited, and everything that you can use. So we have this as a dependency already. And we have also some development dependencies. The most important is SMForge, which is the testing suite of Foundry. And I noticed that I have a discrepancy in the version because I have Scarp, SMForge. Let's see, version 0.45.0. Let me check something because maybe I did an update. Check the actual image. Starknet Foundation, Docker. This is the repository. And if I go to the branch 2.9.4, and if I look at the Docker file, I just want to see what version do we have here. 0.46. So what's happening is that I need to update my own image of the container. So let me close the IDE for a moment. I'm just going to remove that image. Starknet 2.11.4. Oh, have the container still open. Let me stop the container because it's running for whatever reason still, even though I closed the IDE. See my containers. This is probably one running with the image. See, containers. It is stopped. Okay, if I see the images, I should be able to delete this one. Can I delete? Oh, no, it's in use. Who is using it? Let me remove all these containers just in case. Let's try again. Yes. Okay. So now if I try to open again cursor, and if I relaunch in the container with this button, reopening container, it should be fetched now the new version of the image, which should bring with the correct version of SMForge. It's going to take a little longer because now it's fetching the actual image, the new version of it, and then rebuild and relaunch. So let's give it a few seconds. Let me see the chat for a moment. Okay.
Yeah,
Finish relaunching.
question.
Yeah.
I think it would be good if you can answer the question. Is Docker a requirement for this demo?
It's not. If you use a Stark up, that's all you need. I'm doing this because I prefer Docker, but I mentioned you have two different ways to install dependencies. Stark up is just one installation globally of all dependencies, and that's it. With Docker, what you get is that you can have different versions for different projects if you work in more than one Cairo project, like in my case. Okay, so now if I do SMForge, I should have the right version, 0.46. Okay, so now it actually matches what the project is expecting. So we're good here. The rest is more implementation details. I covered the most important parts. So let's go back, see some of the smart contracts. So it comes with one smart contract already predefined when you create a Scaffold project. We're going to create a new one from scratch, but just you can take a look at this as a reference, how to build it. What I want to show here is that you can deploy this to a local Devnet and actually play with it with a local debugger as well. And to do that, we can actually launch the Devnet. So if I open my console, if I open package.json, you're going to see there's a command that says chain at some point. Yes. And that is launching the Devnet. So if I do, first of all, yarn install, it needs to install all dependencies because I skipped that step at the beginning. This is all the front-end dependencies because the Devnet also has some front-end dependencies that we need to activate. Right, take a while, but you only have to do this once. Then the cache will take care of it. Can I use Bun instead of npm or yarn? You will need to do some changes probably. But I don't know. I don't use Bun that often. I don't know how much it's going to change from yarn. But you let me know if it works with yarn. But Bun, it should. Okay, it's taking a little bit longer than I expected. So let's see. If you have any question at the moment, happy to answer them.
Here's one in the chat asking, do I need to change the version for it to work?
The version, you just make sure that the version that you have defined here matches the binary that you have available. Okay, so if you have 0.45, you can either try to update the binary in your computer to 0.46 or just downgrade this dependency here to 0.45. Just make sure that it's the same. Okay, so front-end dependencies are installed. That's good, meaning that now I can run a bunch of commands because the one that I want to run is yarn chain to start the local devnet. And when I do that, you notice that this is like a version of a Starknet running locally that is going to self-identify as Sepolia, even though it's a devnet. But it's going to come from some smart contract already pre-deployed. In this case, the smart contract tokens for ETH and for Stark. So you have those two tokens available. Also comes with the universal deployer contract. This is like a middleware that you will use to deploy any smart contract on a Starknet, in this case in the Devnet. So this also exists on mainnet and in testnet. And then it comes with a bunch of pre-deployed wallets that you can use. They're called the burner wallets. And you can see the address of each one of them, the private key, the public key. So you do use this one just for using like a local development. So now that it's running, I'm going to leave it running here. I'm just going to open a different terminal. Because next thing I want to do, just to keep showing you everything that Scaffold has to offer, I want to first of all compile this smart contract and then deploy it to that local devnet so we can actually see it with a debugger. So let's see, we do that with yarn compile. Just make sure that everything compiles and works fine. The compilation that you're going to get like a target folder with the compilation, the compile file. This is going to be a little slower than last time because a lot of the performance improvements in Cairo came with Cairo 2.12.0. This is using 2.11.4, a little older, so it's a little slower. I actually notify Scaffold if they actually can improve, upgrade dependencies. So the project was compiled. You can see here the target. That's where it lives. Next step, we can actually deploy, yarn deploy. So that compiled file is going to be deployed to the devnet. So let's see how long it takes. Is local level like Katana? Yes, it's like Katana. It's just Katana is mostly for development of games written in Dojo. This definitely is for more generic smart contracts on a Starknet, like your anything that is not gaming. This is what you will use. So okay, so it was deployed. The name of the smart contract is called your contract. It was deployed. This is the class hash, and it was deployed to this address. Okay, so in order to see and to interact with it locally, we can actually spin up like a UI. In this case, we're going to be using the Next.js package here. So we do yarn start. This is going to start the Next.js server with a React program running as well. So now we can open browser, import 3000 localhost. And this should give us, yes, like a local app for us to play with. Notice that it comes with a bunch of wallets. Like if you click burner wallet, you can see all these wallets are the ones that I showed you that came with the local devnet that you can play with. So you can connect with one of them. And they are all pre-funded with a bunch of tokens. So you have plenty to play with. And if you want to debug the contract locally, this is what you're going to actually find. This is your contract that comes with the scaffold and you can play with, right? So you can read some of the properties. These are the methods that return a value, and then you can write to it as well. So we're going to take advantage of this to use local development over smart contract. I just want to show you everything that comes with the scaffold before we start working on it. So I'm going to close this and back to our code. I'm going to stop the front-end server for now. And I'm going to start the devnet as well. Because now we're going to start working on our own smart contract. Okay, clear everything. I'm gonna one thing I forgot to also show you is that it also comes with some predefined tests using Scaffold. Using Foundry. Last time we used the default test runner of Cairo, which is it is great for unit testing, but if you want to do like integration tests or like a black box text testing or testing through the public interface, Foundry is really the tool to use. And that one is called, you can go to Starknet Foundry and you can find the documentation here. So I'm gonna put it here in the chat. We will be using this more in session 5. So no, we're not gonna do any testing today, but we're gonna make sure that the tests are actually running. So make sure everything is hooking up correctly. So to verify that, we do a yarn test. And it could take a little while to complete because this is an older version of the compiler. While this compiles, I want to mention that the Cairo extension has currently some issues understanding these attributes. It says plugin diagnostic unsupported attribute. This is just a confusion from the extension because you're gonna see that the tests actually run correctly. This is something that Starkware is working on to fix, but for now, you're gonna have to live with this issue showing some false negatives. So the test actually ran, Everything passed. We're good. But we're going to delete this because we're not going to do any testing today. That's going to be next session. So empty. And I'm also going to remove this code here, right? So we have a clean sheet to work on. Okay. So let's work on our smart contract. We're going to build like a fairly simple counter smart contract where you can actually initialize with some value when you deploy. You can read the current value of the counter. You can obviously decrease the value. But then we're going to do something a bit more complex. For example, we want to be able, if you are the owner of the smart contract, we're going to find one address to be the owner. You can set the value to whatever, you can set the counter to whatever value you want. Or if you are any user different from the owner and you want to reset the counter, you can also do that, but if you pay 1 STRK, okay? So let's start with a simple one. Every smart contract is good to define. Start by thinking about the interface of the smart contract, what method is going to expose. And we do that with a trait. And we're going to call this trait I counter, right? It's just a convention that start with an I. You can just call it counter interface, whatever you want. This trait is going to require, it's going to expect, you know what, I'm going to disable the autocomplete because last time was also annoying. Cursor, snooze, stop trying to suggest anything. Okay, great. So we mentioned traits last time. It's a way to define things that the smart contract can do. But because this is going to be the interface of a smart contract in particular, we're going to use a specific attribute that comes with a Starknet, which is called Starknet interface. Oops, duplicated. Okay, so now we're saying, okay, this trait is not just a generic trait from Cairo, it's actually going to be the interface of a smart contract. And maybe the first interface we want to define is get counter. Right? Give me the current value of the counter. It's not going to expect any argument, but it's going to return a number. Let's say that the counter is defined as a U32. And sorry, this is not implementation, it's just the signature. So like this. And okay, because this is going to be, the first argument always has to be self, like who is this working on top of? And we're going to pass as a snapshot because we're only going to read from it the generic T. This generic T is going to be the type of the smart contract. It's going to define all the properties. And it's a generic because this type is going to be defined during compilation time. So it's not going to be known right now. Only when the compiler goes through the counter contract, it creates the type and it passes it to a generic. That's why we use it like this way. That's the interface, and I'll actually define the smart contract itself. And the smart contract is defined as a module. Let's call it the counter contract. And in the same way that we had to use an attribute to define, hey, this is not just a regular module, this is actually a smart contract, we need to use specific attribute called Starknet contract. Okay. And it is complaining because it says, okay, if you are a smart contract, you need to have storage, right? That is not optional. So for that, to define the storage of the smart contract, we're going to use a structure or a struct. And that struct has to be called storage. For now, the struct is going to have only one thing that we're going to track in the internal storage. It's going to be the counter and the type U32. We're trying to match the same type here and here. And similarly for, this is not just a regular structure, it's actually the storage of the smart contract. So we're going to have to give it the specific attribute that's called storage. So there you go. This is like a very minimal smart contract with only define what's in the internal state and nothing else. Let's see if this compiles before we go any further. Let's go scarp compile. Sorry, yarn compile. In the meantime, let me see if any questions. What do you use Visual Studio? I'm using Cursor, but you can use also VS Code if you want. Okay. This is compiling. Okay, it's compiling. All good so far. We mentioned that we should have at least one method implemented in the smart contract, right? Right now, these two things are disconnected. This trait lives on its own, but it's not actually connected to the smart contract. So what I'm going to do is I'm going to bring this trait into the scope of this module by using the keyword use. And then I do super, like I want go one level up and bring me the I counter that I created. Okay. So now I can use it here. From session 3, I mentioned that every time you have a trait, you have to define an implementation that goes along with the trait. So this is time to define implementation of this trait in the smart contract. So we do that with the keyword impl for implementation. Implementation in Cairo need to be named. So let's call it counter impl. And then it's the implementation of what? It's going to be the implementation of this trait. So of the I counter. Now it's expecting me to pass, okay, it expects a generic, right? So at this point, I have to pass the actual type, which is going to be defined inside the smart contract as the counter state, right? So this is the specific type provided to the generic type. It always has this thing. So now it complains because, first of all, this is not any implementation, it's any impl, right? We need to say, okay, this implementation is going to be what's called the ABI. And the ABI is really the public interface of a smart contract. So to define that, there's an attribute that is called ABI. And then we're going to say embed V0. There are different ways to define ABI. Embed is one of them. The fact that it's V0 is just because we're trying to be mindful of changes coming in the future, different ways that these things is implemented or handled under the hood. So V0 is that this is the current way. Maybe tomorrow is going to be a V1 with different properties. That's why it has a version. It keeps complaining because say, okay, you're going to implement that, but you need to implement the get counter because you defined that in the trait. So let's go and implement that one. So function get actually can copy this and paste it here. Now, no longer is a generic. At this point, I have the concrete type, the counter state. And now what counter state? What am I doing wrong here? Oh, sorry. This is contract state. Contract, not counter. Contract state. Contract state. Okay. So now what I want to do is to read from the storage and return the current value. And to read from the storage, you can actually access self, which is this one here. Now you can actually read properties from the storage. In this case, I want to read the counter property that we define here. And I use the method read, right? So I can read the value. And this complaint because we are missing some traits in our smart contract. So in order to have these methods available inside self, inside counter, we need to implement some traits here. And those traits is use Starknet, and then it comes from storage. Then we're going to bring two different things. So storage pointer read access, storage pointer read access, and also the write access, storage pointer write access. So these traits are the things that are going to allow me to access this method here, right? So essentially, every smart contract, you need to bring these two things into scope always. Notice that the prefix Starknet here, a prefix here as well. This all comes because we define in the scap.toml Starknet as a dependency. So it comes with, as I mentioned, with a bunch of attributes and macros available in your code. Why we use contract state? Here, okay. That's because the state of the smart contract is going to be defined by how many properties you define the storage and how many functions or how many methods you implement. The fact that you can constantly modify the smart contract and a lot of code is generated under the hood by the compiler, the exact type is not known right now. It's only known when the compiler actually goes through the code and compiles it, and it generates the actual type called contract state. So from that compilation, it actually creates this type that has everything you need, and that's why we have to pass it as a part of the generic. So it creates this massive object at compile type. It called it contract state. That's why the name is. It has to be fixed to this. Okay, so we have the function implemented, the method. The one thing that we're missing though is that who is setting the value of the counter, right? Right now, no one's setting the value. And it's not an issue because by default, every property is initialized by using the number 0. So by default, it's going to return 0. But to make it more explicit, let's actually have a constructor, and then we set the value to 0 more explicitly. So to define a constructor is a function called constructor, and this function is going to expect to be passed, as always, self and the contract state, right? It's always going to be the first argument is the contract state. The question is here, do we need it as a snapshot or as a reference, right? And because we're going to modify the storage, it means that we need to pass this as a reference. So we can actually modify the storage here. And we covered this in the last session. Let me see my notes if I'm doing this correctly. Yeah, contract state. And it says unknown type because I have to annotate this with the attribute constructor. Structure. Why is this still complaining? Oh, right. It's the type I'm missing, the column. This is the type of this argument. Okay. We can initialize when we deploy the smart contract. This function is called whenever you deploy the smart contract, and you can define arguments. For example, we can pass the initial value of the counter. It says U32. So with this initial value, we can say, okay, let's access the smart contract. Let's go to the counter property, counter, and let's write a new value. That value is going to be the init value. So this is how we initialize the value of the counter. So when it's deployed, anyone wanting to interact with it, they can actually go and read what the value is going to be. So let's see if this compiles. It should be, because if you don't see any issue here with the extension, it should be working fine, but just double checking. Let's run yarn compile. Let me see the questions. Okay. Jakub, notice that I missed this column. Thank you. Okay. Running. Let's wait. Okay. Compiled successfully. No problem. Let's now try to deploy this very simple smart contract into this local UI that we used before, just so we can play with it and read values. So in order to deploy this and define what's going to be the value for deployment, there's a file, part of a scaffold, that if you go to a scripts.ts, it's called deploy. Is this the one? Yes. So this is the script. When you do yarn deploy, it actually runs this script. And notice that it's trying to deploy a smart contract called your contract, which is the one that comes pre-bundled with Scaffold. We modified the name, right? We call it differently. In our case, it's called your contract. Sorry, it's called. Oh, notice we made a mistake here because we modified the name country contract, but we didn't change here. So let's call this. I'm going to call this simply. I'm going to call it counter, and update this module reference here to counter. Sorry. Okay. This is okay. We need to use now this name for deployment because it's no longer called your contract. It's called country contract. And thing that is expecting for the arguments of the constructor is not the owner right now. I'm just going to put a comment so we can use it later. But what it's expecting is the initial value. Init val, is that what we call it? Init value. Init value. Let's initialize this. Let's say to 5. Okay. So let's see if it works. We're going to start again the local Devnet yarn chain. And now that it's running, I'm going to go to another terminal. Let's do yarn deploy. So it's going to run this contract, and it's going to deploy the compiled version of our smart contract. Let's take a look. Yarn deploy. Okay, it finished compilation. It deployed the smart contract, the counter contract, deployed to this address. So let's now fire up the UI, yarn start the React app. And we should be able to see it. If I go back to localhost 3000, if I go to debug contracts, this is where our smart contract should live. And you can see it here, right? This is the counter contract. It was deployed to this address, DBE. And if you see the information from the deployment DBE, it was deployed to this address, is correct. And you can see that it has one method, one read method called getCounter. That when you call it, you get the number 5, right? Because we initialize the value to 5. We don't have any write method, and usually the read methods that don't expect an argument, they're displayed here, and the ones that expect some arguments or parameters are displayed here. So okay, this is how you can debug locally your smart contract and play with it. So let's keep working on it. Okay, next step will be to, let's see, let's define 2 functions, one to increment the counter and one to decrement the counter. So I always start with modifying the interface itself. So let's call this one increment counter, or maybe increase counter. And then increase counter is actually going to modify the local state, because it's going to change the counter by updated by 1 more. So it's going to expect the contract state to be passed as a reference now, so it can modify it, right? And it's a generic. It is not going to expect any other argument. It's not going to return any value. It's just going to do the update, and that's it. And then we have a similar word called decrease counter, and very similar. It's going to modify, but just decrease by 1. So it's a reference as well of the contract state. So not a snapshot. So we have the trade. We now have to do the implementation. So let me copy the signature of both of them. I'm going to put it here. And now it's no longer the generic. I'm actually going to pass the concrete type, which is contract state in both cases. And now I have to do the implementation for both. So I only need to actually read the current value. So let's say a new variable called current counter equals to self.counter. We know how to read, right? With the method read on the property. It's assigned to this variable. And then we are going to simply upgrade this by 1 or increase by 1. So self counter right is going to be current counter plus 1. Maybe even easier to read this new variable new or current counter new counter. Let's make it separate. Let's make it here. It's a bit more readable. And then we pass this value to be written back to storage. Okay. And basically the same thing here, but instead of +1, it has to be a -1. Okay. All good. Let's go back to start to deploy this, play with this locally. Let's deploy this again. I will have to open a new terminal. Yarn deploy. In the meantime, you maybe can spot a potential issue here. I wonder if anyone knows that in the chat. What's a potential issue here that actually can trigger an exception or a panic in the smart contract? Yes, actually, you get it right in the chat. This could potentially underflow. The advantage is that because we define the counter to be a U32, we know that it technically, if it tries to underflow, it will fail. It will panic, so the transaction will be stopped and reverted. But the error message will be the error message of the system. We want to maybe have a more descriptive error message for the user. So we can take care of that here. Okay, so it was deployed. So if I open again this, you can see that I have now the two methods for increase counter, decrease counter, that if I click, because I have a wallet connected, you can see the counter should be actually be increased. Just increased by 6, again, increased by 7. If I go down, it actually has the opposite behavior, right? So you can just locally play with it. But we need to take care of the potential underflow of the value. Not because it's not gonna, the system is gonna prevent from actually underflowing, but it's gonna give you an error that's too generic. You want to give a better error for the user. So before we decrement this, let me take my notes. Okay. So to do this verification, we have this assert. We actually used it last time for testing as well. And we're gonna say, all right, if the current counter is more than 0, so all good. You're passing the assertion. But if not, throw an error message, right? And this message could be like the counter can't be negative, let's say. So we can have it like this. So anytime, let's check the logic. So if the counter is 0 or smaller than 0, so the opposite of this, is gonna raise this, it's gonna panic with this message, it's gonna stop this execution, and it's gonna log this into as part of the receipt of the transaction. If the current counter is more than 0, this is gonna continue working here, so no problem. And we can actually verify this. Maybe it's easier if we initialize the counter at 0. So let's do this again. I'm gonna modify the deploy script. It's gonna say, okay, when you deploy with value 0 to make it easier to test. So let's go ahead and deploy this. Take a little while. It takes a while because it has to compile everything again. Okay, deployed. Let's update here the front end. Get counter should be 0. So if I try to now, at this point, decrease, it failed, right? Good. So it prevented the underflow. It's not showing the descriptive error because this is not a block explorer, right? So we cannot see the receipts. I think if you see here, it's not going to show. One thing that the Scaffold team is working on is to have an actual local block explorer so you can see receipts in more detail, so you will be able to see the error message. But if we were to develop this and deploy it to mainnet or testnet, this is the right way to do it. We actually have a more descriptive error message for the user, and it's prevented the underflow. But it's allowing me to increase. So if I try to decrease from 1 because it's bigger than 0, it should allow me to do that. Yes. So we have this underflow protection, even though we have a built-in underflow protection with the unsigned integer that we used. Back to the counter. One thing I want to mention as well is maybe I'm going to come back to this later because I show you maybe my favorite way to handle to group all the error messages in one place so it's easier to reason about. Okay, next step, what else should we do here? Okay, so let's define a new function that would allow me to set the value of, let me see, should I go this way? Try to see what path is more natural to go next. Let's actually deal with the events first, because a common thing or pattern that you use on smart contract that every time you modify some of the internals of the smart contract, you want to raise an event or launch an event that can be indexed by any application with an indexer. So let's do that. Let's define an event. I'm going to call this event, let's see, let's have it here. And it's called this, going to be the events are defined as an enum with the name event. Okay. To be as usual, to tell the compiler, hey, this is just not a regular enum, this is going to be an actual event, we need to have an attribute called event. Now this attribute needs to have some extra traits applied to it. And to apply traits to a custom type, we use the keyword derive. We use this in session 3. And we're going to, first of all, use derive the trait drop, so it can be dropped from memory. We also see this in session 3. And then we're going to have to use another one called a Starknet event. Okay, so you need all these attributes in order to define this enum as an event. So now we can define what type of events we're going to have in the smart contract. So the one I want to define is called counter change. Okay, and counter change is going to be a struct that is going to have the value. For example, what is the old value, what is the new value, and who made the change, and for what reason. Because it's a complex type, I'm going to define a struct that defines all these properties, all these members. And just for simplicity, I'm going to call the struct the same name as the member of the enum. Counter changed for both of them. But this one is going to be a struct with these properties that I'm looking for. So for example, this struct counter changed, as I mentioned, is going to have a few properties. It's going to have, as a public, it's going to be the caller who is making the change. And the change is going to be of type contract address, because it's going to be the address of the person making the change. We need to bring this into scope, and that is defined under Starknet. Okay, contract address, right? This is essentially a felt. Okay, it's called contract address, make it more readable. We're going to also log what was the old value, right, before making a change, because the change could be increase, decrease, or you just set the value or reset. It's going to be U32 because the counter is U32. Then it's going to be the new value, U32. And then we're going to have the reason why we're making the change. And for this, I'm going to create another enum, so I can define with enums what are the changes. And this enum, I'm going to put it here, enum change reason. And this could be, it's complaining because most define a storage struct. Okay, this needs to have some traits implemented. Okay, for now it seems to be working. Let's go back to this later. But I can call this event for different reasons, right? Increment, decrement, or set, or whatever. So let's find it here. Could be because I increase, I decrease. Could be because I did a reset, or could be because I set the value to something, right? This is basically matching the 4 methods we're going to have in the smart contract. And this enum needs to implement some traits, as always. We're going to need to have the drop, copy. We covered this too. And service. Service because we want to be able to serialize the value. So this is correct. Now for the struct, we also need to define some traits. In this case, drop is always required. And then this is part of the event structure, so we need also to define event. Okay, so we have the top event that you can define multiple events in your smart contract. And then if you want to have like a custom types for your events, and you want to publish different things when you raise the event, you create a custom type with a struct. And then you define, okay, these are all the things that are going to show to the world that is happening. They need to be implemented, derive an event as the top enum as well. And then if you want more details about reasons, in this case, we define an enum with 4 different possibilities for why this event was raised. I think this pub is not required right now. I think it's going to be part of the testing that is required. So I'm going to make it simple. Pub is just making it public, so it's accessible from outside the smart contract. Right now, we only going to use this internally. Okay, so the event is set up. So now we need to be able to use it. So every time we modify the state, we're going to raise the event. For example, here, right? So after we write, let's see, do self.emit. This is how you emit events. And then we tell, okay, which event do you want to emit? And this is going to be why it is complaining. Wrong number. Okay, expecting more things. Okay. You're going to, let's click here the let event. This is going to be of type, the event that we define, counter changed. We define the struct here. And we need to define the old value. Let's call it the current counter. Then we have the new value is the new counter. We need to define the color. And to get the color, there's a method we can use, or it's called get color address. And I believe we have to bring this into scope, if I'm not mistaken. Get color address. Where does the import come from?
Yeah, we'll
Okay.
bring it to scope address.
From here.
Yes.
Get color address. So you were saying, Truth?
Yeah, I was talking about the import of the get color address.
Yes. And the thing we're missing now is the reason, right? Reason. And this is going to be one of the different enums. So we're going to bring to is it a reason? How do we call this? We call it change reason. So change reason. And this is going to be increase. So we have defined the struct that we want to use. And now we can pass it here. It's going to be the event. Okay, let's see if there are any questions so far. So because I want to raise the event, after it's defined, and I actually create the struct with all the members I want to be emitted. And this is how I actually get who is the one calling the smart contract. So I pass it as the caller. I use the enum as to say, okay, which of the reasons that I define is the one associated with this event. And then I use self.emit and the actual struct that I created to emit this event. One thing that is missing though, in every event, you should always have one property indexed. This is for performance reasons. When there's an indexer trying to index this event to be served to another app, you define at least one as a key. In this case, I'm going to define the caller to be the key for indexation. This has to be with how database is going to be working. Okay, so we have the event for increase. Let's have the event for decrease. So I'm just going to copy paste this. So as soon as we decrease, we have this and we have all the values. We have the current counter, we have the new counter. This is the same, but now the reason is going to be decrease. Okay, and we're going to emit this event. So let's have some space here so it's more readable. Okay, let's give it a try. Let's try to compile this. Clear, yarn deploy. It's going to compile, it's going to deploy. This is going to make more sense when we go to the final session, when we build the UI and we can actually read the events and do something with it, maybe display who's making what change. But at least want to make sure that it is in the smart contract and it's working as expected. Questions while we wait for the compilation and deployment? Maybe after this part is done, we can go on a break and come back for the rest. But for now, it's been deployed. So if I go here and refresh, one thing is that we are not going to be able to see the events, I believe, in this debugger. Check out transaction. This is not, this is open mainnet, but it's not really mainnet. Anyway, when you go to session 6, we're actually going to display all the events. But the fact that it's working and no errors has been raised, it means that it's probably working. We're going to see shortly. Session 5 during testing, we're actually going to test that these events are being raised when it's supposed to be, and it actually has the right shape. So for now, we're just going to have to blindly trust that it's working. And let's focus on the next feature we're going to add. So we have the feature to get the current value, increase, decrease. Let's have now a feature where we can actually set the value to whatever we want, but this function can only be called by whoever we define as the owner of this smart contract. So before we do that, we need to define who the owner is, okay? And so we're gonna have to track it here. Define a new variable called the owner. And this is gonna be an address. So it's gonna be of type contract address. So now when we deploy the smart contract, not only we say who's the initial value, we also say, okay, who is gonna be the owner? And we're gonna put here, the owner is gonna be contract address. And we're gonna capture that and put it in the storage. Self, we call that the owner property, but also right. And then we pass the owner. So now we define who the owner is going to be. And to be able to actually track this ownership and have a bunch of functions connected to ownership, we could implement this all manually in the smart contract, like how to change ownership, how to renounce ownership. But we can reuse something that already exists and it's already been audited and is safe to use. In this case, is OpenZeppelin. Because if you go to OpenZeppelin Cairo, there's a whole suite of libraries that OpenZeppelin provides, resources, documentation. Is this the one for Cairo? Contracts? I don't know if I'm looking at the Cairo or the... No, this is the Solidity one. How do I navigate? It's always difficult to find the one for OpenZeppelin for Cairo itself. Go back. Cairo Smart Contracts, OpenZeppelin. Docs. Let's see, contract for Cairo. Current version is 3. Okay. Oh, it's alpha 1. We are using actually version 2. If you take a look at the scarp.toml, we are using 2.0. Okay. So we're going to look at this documentation, and you can see that there's one for access module. This is one API reference, and you should have the ownable component. This is the one we want to use, the ownable component. And that is available if we bring it from this scope. So let me show you how this works little by little. Okay, back to the code. Let me take a look here. Okay. Great. So to bring a component is basically just a reusable piece of code. We can just plug into a smart contract and we have all these things for free. We're going to use a macro called component. And in here, we're going to define path, the storage, and the event, because we can bring multiple things from the component. In this case, we're interested in whatever the storage is required to bring the component and whatever events this component wants to raise, whatever something happens with like ownership change. I want this to raise the owner change event on its own. So let me bring into scope this OpenZeppelin component. So it's going to see use OpenZeppelin. And we're going to bring, in this case, the access, right, for the owner. And going to be the ownable. And I want to have the ownable component. Okay, we have it now in scope. So now we can say, all right, this macro expects, first of all, the path. Which component do we want to bring? You want to bring the ownable component that we just defined. The top ownable component. Yeah. Second argument is storage. We're going to call this, whenever we bring this into our system, we want the storage to be called ownable. So it's gonna use part of our storage to put whatever the component needs as well into the storage of our own smart contract. And the same with the event. We want this event to be called the ownable event. Ownable event. Let me see if I'm missing something. Ownable event. What is here? The ownable. Ownable is not to be storage mirror. Okay. Okay. Great. So we need to tell this now. We need to mark where this storage ownable is going to be placed and where this event as well is going to be placed. So let's start with the storage, right? We have the storage here. So instead of us manually handling who's the owner, we're going to delegate that task to the component itself. So I'm going to remove this for now. I'm going to say, okay, I'm going to define this property ownable, which is the one that I define here. And instead of being me defining what goes into that property, I'm going to delegate this to the ownable component and the storage, right? So whatever is in the storage for this component is going to be placed in this property, right? Second, we want to also delegate to the component to raise whatever event it needs when ownership is modified. So, oh, sorry, there's one thing missing here. I need to have an attribute called substorage and then v0, right? Just to make it clear that this is going to be a storage managed by the component as a sub property of my main storage of the smart contract. Okay, next up. So this is actually going to be handled differently. I'm going to go back to that later. The event. Okay, so we go to our main event enum. This is where we define all the events in our smart contract. We're going to find a new entry. Let's call it the ownable event, right? This is the name we give it here. So say, hey, this is where we're going to place it. And the type is going to be the ownable component event. That's correct. Identifier not found. Ownable component. That's why misspelled. Same as with the storage, we need to have some attribute defined here because we want this. We don't want to create a whole new sub event that leads to another sub event. So I want to have a flat structure as possible. So indexation is a bit easier. So in that case, we use this key called flat, right? Just to help with indexation. All right, so now this event is going to be handled by the component, and this storage is going to also be handled by the component. All good so far. We now need to bring some ABI because the ownable component brings its own public interface for a smart contract. We need to make it available here as well. So I'm going to basically define a new extend the ABI smart contract, ABI embed v0, similar to what we did before with the implementation of our own trade, right? We have the same. It's just this is the ABI that we define, and this is going to be the ABI that is going to be brought by the component itself. So the implementation, let's call it the ownable impl. It could be any name, but it needs to have a name. And this is going to come from the component again. Ownable component, then ownable implementation. And then we pass the actual, the type of a smart contract or the storage. So the component knows how to handle everything that we find in a smart contract, in this case, the contract state. And we're going to need to have access to some of the internals of the implementation as well. So internal impl, it's going to be the same ownable component. It's just in this case, that's going to be the internal. I'll try to explain this a bit more. Maybe in the docs, it's going to be easier. You can see that this is the ownable implementation we're bringing. And if we see here, it's bringing all these functions, ownable implementation. It's going to be called the owner function, transfer ownership, and renounce ownership, right? So this is going to be part of the ABI of our own smart contract provided by the ownable implementation. And the only thing that we need as well, we also bring in the internal implementation, right? If you take a look at the code, we have the ownable implementation and the internal implementation. And we need to bring this one here because we need to be able to initialize who the owner is as part of the constructor, right? And we want to be using this method as well as part of our functions to stop or to prevent anyone who is not the owner from trying to set the counter to a certain value. So let's first use this initializer in our constructor to set who the owner is. So we're going to say, I'm going to see, okay, self.ownable right? Ownable, because that is the name we gave here to this sub storage. And now we're able to access the function initializer. Right? Able or not. Right. So through this, now this function initializer is the one that is defined here. I have access to it. Okay, so this is how they find who the owner is during the deployment of the smart contract. Now we can actually create the new event, or the new method. It's called function set counter, that we set it to any value we want, but only the owner will be able to do this. And because this is modifying the actual counter, it expects to be a reference of the contract state. And now we can implement that here at the bottom. Function set counter. Counter. The first argument is the same. It's a reference to contract state. But now it expects to say, okay, to which value do you want to set it? So let's set it to a new value, U32. So as we mentioned, we want this method to only be called by the owner. Anyone else who tried to do this, we're gonna fail the execution. So to prevent from anyone else to do it, we're gonna call again the ownable substorage, and then we can actually access the method assert only owner. And again, this is a function that comes with the internal implementation, which is the one that we inputted here. That's why we brought this implementation into scope. Okay, we brought this so the ABI exposes all these things to change owner, who's the owner, all that. We brought this to be able to initialize the owner and to prevent anyone from accessing certain methods if they're not the owner. Okay, so now if you make it to this line, meaning that if you are the owner, you're gonna make here, because otherwise at this point, there's gonna be an assertion that's gonna fail, it's gonna revert and everything. So now we can actually modify the counter. So we're gonna say, let all counter, we read the current value as before, maybe similar as here. Actually, let me copy this, because the same, we first read, and then we actually set the value. So we're gonna copy this, set the value, it's gonna be new value, right? Why is this failing? Wrong number of arguments, expecting 1, found 2. That's because I forgot to define here that there is another argument, new value. So type U32, right? That's what it was complaining there. All good. So I'm setting the value to whatever is provided here as an argument, only if it's the owner who's calling. And if it does successfully, now I can raise the event. So let's define here all the values. So current counter, new counter, it's actually, we call it new value. So let's put in the right name, the correct address, and then the reason is going to be set. I'm setting the value. So now we can emit the event. And let's give it a try. Let's give it a try. Let's take a look, because now our constructor is expecting an owner to be provided when being deployed. So we need to go to the deployment script. And in here, we're gonna uncomment this. So the deployer is passed as the owner, okay? Let's give it a try. Let's try to deploy this. See what happens. Let's see if you have any question. Questions about quiz? There's going to be a quiz today in a few minutes. So stay until the end. All right, compile, deployed. Let's take a look in our debugger. Let's refresh this. Now notice that we have a method called owner that is returning who the owner is, right? This address 691, which corresponds to the first address in our burner wallet, right? 691. So we are connected as the owner right now. And notice that This is our new function, set counter, which expect a new value. But also there's some methods, transfer ownership, pre-announce ownership, that we didn't define directly, but they come from the component. This is why we actually had this line here. It's coming from these two lines. It says, whatever is defined in this implementation, make it part of the ABI of my smart contract. Right? So I didn't have to do anything. So I have now two new methods that are part of my smart contract that comes from OpenZeppelin, and it's all being audited. So let's try to, the value is right now 0. So if I try to set a new value connected as the owner, right? 5691, 5691. So this should allow me to do it, right? I can go to 10. So it's 10. Yeah, I was able to go through, set the value to 10. Now, if I try to connect with another account that is not the owner, for example, this one, I should get an error here. So if I try to set this to 5, yes, failing. Right? That's what we want. We want only the owner to be able to change, to set the counter to whatever value he or she wants. So this is working fine. I know component is a little complex, the way to use it. The reason is because you want to make it as flexible as possible, because in a smart contract, in a complex smart contract, you probably use more than one component. So you want to make sure that when you bring all these components, there are no collisions in the names, either for the storage or for the event, because it could happen that two different people develop two different components and maybe they define the same name for something. So this is preventing from this collision to happening. And this is how you do it. So to recap, first of all, you bring the component into scope. In this case, we bring it from OpenZeppelin, the ownable component. Then you define with a macro component which component you want to bring, which storage property you want to extend with whatever the component wants to add. In this case, you say, okay, the property ownable is going to be part of that. And you define, okay, which event do you want to add that is controlled by the component. Then we define, okay, do you want to expand your ABI with something with the component? Say, yes, please bring the method defined in this implementation to the ABI to my own component. That's how we got transfer ownership, renounce ownership, and also owner. And then we can bring more like internal methods or functions we want to use. We actually need it in this case because we want to be able to initialize and to call the method assert only owner. And then we say, okay, this event is going to be controlled by the component, and this name has to match what we define here. We say this particular storage entry is going to be controlled also by the component, and this property name has to match what is defined here. Okay, this is a high level what we did to bring a component. And the next and final step is that I want to create a function that is going to allow to reset the counter back to 0 to anyone. Anyone can do it, but you will have to pay 1 STRK to do that, right? It's going to cost you, and that STRK is going to be paid towards the owner of the smart contract. So first of all, let's define the trait. So function is going to be called reset counter. In this case, because it's going to modify the internal storage, it needs to have a reference. And we don't need to find new value because it's going to reset to 0. So let's go to the implementation here. Function reset counter, which expects contract state we pass as a reference. Contract state. So what does it do? All right, let me take a look at my code. Okay, first of all, we need to define how much people are going to pay to make this change, to reset. So the payment amount is going to be of type U256, because anytime you define a balance or a value that is connected to a token has to be U256. It's going to be 1. Now, this one is not 1 STRK. This is like a 1, similar to a way. I forgot what the name is for a STRK. So to make it actually 1 STRK, you need to add 18 zeros, right? Because in a smart contract, you always use 18 decimals for any value connected to a token. So it will be annoying to do like 1, 2, 3, 4, 5, 6. I mean, you can do it. You put 18 zeros on top of that. But I'm going to create like a function to do that for me, a little bit more easy. Let me see, deploy. Let's have it. Do I want to go all the way? Let's have it for now, just like a one way or whatever it is, the small unit. And then we try to increase to 1 Stark to make it more easier to see. The payment amount, no, wait, 18 decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Hopefully this goes right. Okay, this should be one Stark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, it should be 1 Stark, 18 zeros. Next up, we need to define, okay, we're going to be connecting, we're going to have to talk to the Stark smart contract, because there's a smart contract that defines the Stark token. And the address is actually well known. The address is always the same, either on mainnet, either on testnet, either even on Devnet. And we can see the address here. When we deploy if you can still see it, here's the chain. Can we still go back to the beginning? We cannot. But it was defined that when the chain, when the Devnet started, it gave you the address of the Stark token, the ETH token, and all the smart contracts, the wallets. But you can go to a block explorer like a Stark scan. And in here, I think there's like an address book. And you can see the Starknet token. This is the address, 938D. Because even if you go to testnet, it's the same. Actually, let me go back. Let me copy the value. I'm going to copy this. I'm going to Sepolia, paste the value, and you can see there's also the Stark token. And it's also in the Devnet the same. So it's safe to use a constant to define this value. So let's have it. Let's have it here. Let's call this the Stark token. This is a contract address, and the value is this. Is this possible? What am I doing wrong? This failed to 52. Wait a second. Where's not a contract address? I need to put it like this.
You can put the try into dot unwrap.
Oh, trying to.
Yeah, the try into then dot unwrap after the number. It will have OX at the start also.
So here, Mr. Token semicolon.
0x.
Okay.
Yeah.
All right. Thank you. Yes, I'm turning the actual address into a contract address. So from a failed to a contract address. Good. I have the token address now. I need to see if the caller actually has enough balance to pay for it, right? So let's create this function balance, this variable balance, and we are going to create what's called a dispatcher. And a dispatcher is a way it's like a function to interact with any other smart contract. And a dispatcher is created by the compiler through this Starknet interface attribute. So we're going to use OpenZeppelin once more. Let me see. So it's called the Yes, we need to bring something from OpenZeppelin first. These interfaces. And that is going to come from use OpenZeppelin. But now we're going to access the token, right? We have two dependencies, access and token. And in here we can bring the ERC20, which has the interfaces that we're looking for. It has two things that we like. The ERC20 dispatcher, and we're going to use this to communicate. And the dispatcher trait, which is going to bring all the methods that we need for this interaction. Dispatcher trait. Okay. So instead of defining our own interface for ERC20 token that is, we know how it is, but we don't need to do it by hand. We can just go to OpenZeppelin and use the interface they define. So now we can actually make the call, ERC20 dispatcher, and we can actually tell, okay, this expect a few properties. First of all, what is the address of the contract? Contract address. We define this in the Stark token variable. We put it in a different line. That is argument number 1. This is a struct, by the way. And we also need, what else we need? Oh, that's the only property we need. Just knowing the address, put it just in one line. So now I can actually call one of the methods of the ERC20 contract. In this case, I want to call the balance of. So I can pass it an address, and it's going to give me back what the balance is for that person. And the person I want to know the balance is who's calling this function. So let caller, let's use the function get caller address as before, and we pass it here, caller. Okay, so we capture the address who's calling, and we say, okay, go to the start token contract and search what's the balance of this person. So now we have the first assertion. So we're going to assert that the balance is at least has to be bigger than the payment amount. Payment amount could be bigger or equal, right? So you have enough to pay. If you don't have enough to pay, say you don't have, or user doesn't have enough balance. User don't have enough balance. User doesn't have enough balance, right? So if you don't have enough from this one Stark token at least, you cannot continue, right? You don't have the money. Next thing we can check if you had the balance. So now we're going to check if the smart contract is allowed to actually manage the token for you. This is the allowance. So we're going to have something very similar to this. We're going to call this the allowance. So we're going to use the same dispatcher, ERC20 dispatcher, same contract address, start token. Can probably simplify this, but we can do this later. But now I'm going to call the function allowance. And the allowance is expecting a couple of arguments. First of all, the question is the allowance of who? The caller. And check if a caller has approved sufficient allowance, get caller address. This part is I'm confused. Is it the same here, caller? Let me see what it says. Oh, owner and spender, contract address. Oh, okay. I noticed that I have an error here because I don't know.
So the owner will be the caller and the spender will be the contract.
Yeah, but how do I get the address of this contract?
So as we have like get caller address, we also have get contract address.
Oh, nice. That's a good one. So let's bring it into scope. Get contract address. Nice. I was missing this. So we can make it into a function here, contract. And say get contract address. So we can see this. So this answers the question, okay, does the contract has enough allowance to spend from the caller? Is it allowed to spend from the caller? Like how much can you spend? And we do another assertion for this. And it's basically if the allowance is greater or equal than the payment amount, we're good. If not, says contract is not allowed to spend enough Stark. Right? So, okay, so you have the balance, you have the allowance. So if this all goes through, now we can finally transfer the money. So let's do this. Let me do a simplification. I think we can just create here a dispatcher. not rewrite this over and over. We put this here, and then use the dispatcher. So to make it a little more concise, because we're going to continue calling this. Because the next call is to actually send the money. So we're going to call the function transfer from. Transfer from. And we're going to transfer from the caller to the owner, right? The owner is going to be the one receiving the money. And how much they're going to get? They're going to get what we define as the payment amount, the one STRK. And the owner, actually, we need to bring it from the storage. So let's click here, let owner is equal to self, owner, ownable, get owner. What's the name of the function? Oh, owner. Ownable should be the owner method. Okay. So now we transferred the amount of money. And what else? We capture if this was a success or not. So let transfer, let's call it success. See. Okay. So now we do an assertion. So if this is not successful, then we can say success. Transferring STRK failed. And finally, if this all goes through, now we can actually modify the state into the reset. So we need to first get the current value, essentially similar to what we did here. We get the current value, and then we set to 0. So the current counter, read it, and then we actually modify it. Self counter, write. I'm going to set to 0. This is the reset. Now we're going to raise the event, right? So let me copy the event from here, and you just modify it. And the new value is going to be 0, and the reason is going to be reset. Reset, and we have the caller already, so we don't have to call this again. And we emit the event. So to recap, we define how much money to pay. We define what is the address of the contract. We can do the hard coding because it's always the same address for the STRK token in testnet, mainnet, in Devnet. We capture who's the one calling the smart contract. We capture the address of the smart contract itself, where it was deployed. We define the dispatcher so we can actually interact with an ERC20 token, in this case, in particular, with the STAR token, ERC20.
Now, two things you tell me. First of all, you tell me, say me apply for proof of share.
How do I? Okay, I think it was just Truth unmute himself.
Oh, so sorry.
We check the balance. We check the balance of the caller to see if they have at least one STAR token. If they don't, we stop the transaction and revert. We check then if the user gave the smart contract the permission to actually spend tokens on his behalf. This is called the allowance. We check if the allowance is enough to pay for the one STAR token. If we do, if it doesn't, we stop. And if it does, it means that we now can actually do the transfer of the money. We are going to transfer from the caller, send to the owner of the smart contract, one STAR token. If it all goes through, we reset to 0, and then we emit the event of reset with the value of 0. There's a lot going on here. But this is the last method we're going to create. Let's try to deploy once again. And we see if it works, because after this, we just launched the quiz and we are done for today. Questions so far? Yes, you wanted me to rewatch this after to let it all sink in. But there's a lot. We covered a lot of things today, but it's all very useful for a smart contract. Okay, it's been deployed. We see this. Okay. Let's see the STRK. So we can see the methods. We should have now this reset counter is here. Transfer ownership. Okay. So let's see if it works. Let's define this, increase this to something, say 2. Now, if I try to reset right now, it should fail because I have not given allowance. I have not allowed this contract to actually touch my tokens, right? It failed. To allow this, I will need to copy the address of the smart contract. I go to the start token. I need to go to the allowance. Transfer, there's a lot of method. Is it a, I think it's a proof. Yeah, decrease allowance. Yeah, I think it's the proof method for this. So I'm gonna allow this address, which is the address of the smart contract of the counter. And how much I'm gonna allow? Let's say 10 STRKs. So I put 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Hope that's right. Send. Okay, so in theory, now I given permission to the counter contract to move at least 10 tokens on my behalf. So if this is working, I should be able to reset. Yes, I was able to reset back to 0 because I paid 1 STRK token. You can see it went down 1 STRK token. Yes, it's working. You only have 8 minutes left, so I'm gonna launch the quiz. Question, did you approve the token before? Yes, I did it here. In the STRK, the STRK is also deploying the debugger, so I just call the approve method and pass the correct values to the recording.